restricting the domain worksheet. And one of the things we were talking about is that an inverse must be one-to-one. Now let's analyze a little bit more what that means. If a function's one-to-one, then there's only one x for every y and for only one y for every x. So the function needs to pass the vertical and the horizontal line test. So if you see what I have on the page here, if I do the vertical line test, the first function passes the vertical line test, the second function doesn't. The third function does pass the vertical line test. Now let's check the horizontal line. The first function does not pass the horizontal line test. The second function does pass the horizontal line test. It only hits the function in one place. And the third function also passes the horizontal line test. So the only function here that is one-to-one is this last one. The quadratic on its side, or straight up and down, is not one-to-one. So what are we supposed to do if a function is not one-to-one? So what we're going to look at here is this quadratic function, f of x. And I've already got the graph pulled up. Here's the graph of the function. This is Desmos. If you haven't used it before, it's free. I've talked about it in class. But if we notice, looking at this quadratic does not pass the horizontal line test. So what we want to do is restrict the domain. So if I go to my vertex that's located at 4, 1, and I restrict the domain, I can either restrict it for every value less than 4 in the x direction or every value greater than 4 in the x direction. So I'm going to go with every value greater than 4. So my vertex is at 1, 2, 3, 4, 1 right here. And this graph is going like this. So I'm going to restrict my domain of f of x so that it's just every value starting at 4, including 4, up to infinity. The range, let's talk about the y values. The range of f of x is going to go from negative infinity. Notice that arrow is going down in the negative direction. Negative infinity up to 1 in the y direction, stopping at 1, including 1. So my range starts at negative infinity and comes up to positive 1 in the y direction. So what we've learned about inverses is that the x and the y will all switch. So I should already be able to tell what my domain and my range of my inverse function will be just by looking at the domain and the range of the original function. So let's go ahead and write that down. Whatever the range was of the original function will be the domain of my inverse function. And whatever the range was, whatever the domain was for my original function is the range of my inverse function. The domain and the range will switch between the inverse functions and the original function. So let's look at what this is graphically. Okay, let's look at what this would be graphically. I'm going to go back to Desmos. I've already done some pre-programming with Desmos. If you are new to Desmos, don't think you need to know how to do this. Okay, so what we did was we restricted the domain. So now you see how half the parabola is dotted. We restricted the domain to not include that dotted line. And then we can look at the inverse function. The inverse function is here in purple. This is the inverse function. The solid purple graph is the inverse function of the solid red graph. Those are inverses. They are reflected in the dotted green line, which is y equals x. These are inverses. Both of the solid lines will pass the vertical line test and the horizontal line test. So your inverse for this first example should end up being, when you solve algebraically, the inverse of x of f of x should be the square root of negative x plus 1 and then plus 4 on the outside. It's a square root function, which makes sense. Our original function was squared. The second case we need to examine when restricting the domain is inverse functions that are not one-to-one. So if we look at this example, the square root function is one-to-one. And if you're not sure what the parent function of a square root function looks like, let me just sketch a graph. This is what a square root function usually looks like. Okay. Now this square root function has an a value that's negative, so ours is going to be reflected down because it's negative, and then it has a minus 2, so it's going to be a horizontal shift to the right 2 and a vertical shift up 3. So if I'm sketching our f of x function, it's going to go over 2, up 3, that will be our starting point, and then it's going to grow in the negative direction. Right? Our a value is negative, so this is going to grow this way. So that's just a basic sketch. If you're not sure what the graph should look like, then go ahead and either use Desmos or make a table of values. But this is approximately what f of x should look like. Half of a parabola turned on its side. Now we need to find the inverse of this function. We need to find the inverse of f. So we go ahead and we switch the x and the y. I'm going to have x equals negative the square root of x minus 2 plus 3. We have to undo everything happening around. Sorry, I didn't even write the y. Switch x and y. That value should be a y. We have to undo everything around this y. So first I have to subtract to the 3. I'm trying to get y by itself. The first step is to subtract the 3. X minus 3 equals a negative square root of y minus 2. Now I need to undo this negative outside the square root. I can't get inside the square root until I get rid of this negative. So I'm going to distribute a negative 1. I'm going to multiply every term by a negative 1. So negative 1 times x is negative x. Negative 1 times negative 3 is a positive 3. Negative 1 times a negative square root, that's going to make it a positive square root, y minus 2. Now I am able to square both sides. To get rid of the square root, I need to square both sides. Notice how I squared the quantity negative x plus 3 squared. I have to square everything on the left side of the equal sign. I have to square that binomial, and that will be equal to y minus 2. Our final step here will be to add the 2. So our inverse, our final inverse, is going to be a quadratic. It's negative x plus 3 squared plus 2 is our inverse function. Now that's a parabola. That inverse function will make a parabola, so we need, which is not one-to-one. So we need to go back to our original function and think about the domain and the range. And we have to make sure the domain and range of our inverse is restricted similar to our original function. So if I look at f of x, in the x value, it starts at 2 and is going off into a positive infinity. So our domain of f of x is going to be 2, notice the bracket, to a positive infinity. The range of f of x is going to, its maximum is at 3, and it's going down to negative infinity. So the way I write it, lowest value first, so I have to start with the negative infinity up to 3, inclusive of 3. So this is our domain and range of the original function. Well, we can use that to come up with the domain and range of our inverse. So the domain of our inverse function, look at the range of the original function, should be negative infinity to 3, and the range should be positive 2 to infinity. I hope this helps you complete the next two problems on the right side, or the next three problems.